Hello everyone. Today we will discuss about Venturi meter. In this video, we will discuss about working principle of Venturi meter, applications, advantages and disadvantages, parts of and material of Venturi meter, technical specifications, straight length requirement, technical data sheets, vendor calculation review, dimensional drawing review, installations with transmitter and reputed supplier. Working principle of venturimeter. The working principle of venturimeter is same as orifice meter because venturimeter is also called DP type measuring instruments. So basically it is measured the differential pressure which can be converted into flow. So the principle behind the operation of venturimeter is Bernoulli effect. The Venturi measures a fluid's flow rate by reducing the cross-sectional flow area in flow path and generating a pressure difference. Just like a orifice meter where we reduce the cross-sectional area of the orifice which is called bore where pressure will be decreased. So there will be difference in pressures because upstream pressure will be more and downstream pressure will be less. Similarly, here also in Venturi meter, we reduce the downstream cross sections area which is called throat. With the help of this reduced area, there will be differential pressure generated that is measured by electronic transmitter and can be converted into flow. Here is the flow formula that can be used to measure the flow rate. The upstream pipe size is D1 and the throat pipe diameter is D2. Again, this downstream is pipe diameter is D1. So these types of shape of venturimeter can be formed and there will be differential pressure within upstream and downstream pressure. Upstream tapping can be here, so we can measure the upstream pressure from here and downstream pressure we can measure from here. This is the cylinder part and this is also cylinder part. This section is called reduced part. This is also reduced part. This angle is 21 degree, this reduction is 21 degree and this reduction is 6 degree. This is called head loss. In other language it is called permanent pressure loss. So there will be a differential pressure across this Venturi meter. This head loss or permanent calculation loss is about 10 to 20% of this head loss. So we need to calculate the head loss also because we have to compare our head loss with respect to available or allowable pressure loss. So fluid will be passed from this inlet side to outlet side and by these two tapping, one is HP and second one is LP, we can get this differential pressure. This differential pressure will be sensed by a DP transmitter and that value can be converted in flow. Application of Venturi meter can be in water and sewage plant, slurry fluid in mining applications and chemical plants, power generation plants, oil production and refineries, hydrocarbon liquid and gas process, LNG trains, compressor station, cryogenic applications and steam applications. So we can see there are lots of applications of Venturi meter. It is most widely used flow instrument in EPC sector. The advantage of this Venturi meter is that it is suitable for liquid gas and steam applications. Mostly for every types of fluid we can use the Venturi meter. Its accuracy is more than orifice meter, so it can be get up to 0.5% of actual flow rate. Low pressure loss. If we see the design of orifice meter, then there will be a cross-sectional area that is called bore. So there will be very high pressure loss. But here in Venturi meter, this cross-sectional area is slightly bent. Due to this, the pressure loss is very low. So in that applications where low pressure loss is required, then we can use the Venturi meter in that applications. Wide range of sizes are available. Orifice meter, magnetic meter, Coriolis meter, vortex meter, these types of meter have size limitations. But Venturi meter can be used for bigger sizes also. From a particular supplier, we can use 104 means 104 inch of Venturi meter. So you can assume the size of Venturi meter so that we can get a wide range of flow. It can be installed vertically, horizontally and inclined. So there will not be any installation limitations. They are more precise and that can be used for wide range of flow that we already discussed, although the bigger sizes of meter is available, so we can get a wide range of flow. About 90% of pressure drop can be recovered. So around 10 to 20% pressure loss can be there in Venturi meter, which is very low as compared to orifice meter. Less chance of getting stuck with sediment. So that is why we can use the slurry in the slurry fluids in many chemical plants. There are some disadvantages of this meter, like they are large in size, therefore space is limitations, so we cannot use in that application. So it is required more space to install. Initial cost installation and expensive maintenance is also expensive because its size is very high, so maybe material cost can be more, and due to the high weight, more weight, we have to pick up with some equipment, and we can lay down on the pipe, so we have to provide some support also. So initial cost and installation can be expensive. Maintenance is not easy because the take it off from the pipe and install again is very tough for this Venturi meter, because for bigger sizes it is very heavy. Required a long placement length, that is, the Venturi meter must be driven by a straight tube, that is so that has no connections of misalignment to avoid the turbulence and the flow for satisfactory options. So these are the disadvantage also. Parts of Venturi meters. So there are two types of design. One is flanged design and second one is welded design. So if we are using the flange design as shown in figure, then the following parts will be there: flanges, pressure taps, conversion cone, throat and lifting lug. So you can see this is the flange of inlet side, this is the outlet side of flange, this is the lug, this is also lug, this is the downstream or low pressure tapping, and this is the upstream tapping. This is the straight cylinder. Now this is the reducer, and this section is called throat. Again this is the expander, and this is the straight sections that can be seen in following drawings, which is very clear. These types of design will be there in Venturi meter. So these are the pressure tabs. So this is the Venturi meter. If we talk about the material of the Venturi meter, then whenever we will select the material in any projects during the engineering and design, then we must follow the piping material specifications. PMS is a document can be found from piping department, where each and every pipe details can be there. So basically Venturi is a special types of pipe. So for this material we can use the PMS. So our Venturi meter material can be same as piping material but not low grade than piping material. So in that particular pipeline we want to choose a material of Venturi meter, then we can follow the PMS, that is called piping material specifications. Some common or standard materials are available in the market like carbon steel, low temperature carbon steel, stainless steel 304L, 316L, duplex material 2205 to 2507, chrome alloy, CRMO P11, chrome alloy CRMO P22, or any other special material also can be take from the vendor on special request. So this is few drawings. One is fabricated with flange end, second one is fabricated with bevel end where we want to make the welding, and this is the machine with flange end where you can see from the outer side you can see it is the just it look like pipe, but inside there will be these types of arrangement will be there. So this is this hollow portions will be machined with special types of instruments, so end will be flanged only. And this is also from outer side you will see just like a pipe, but inside this types of machine will be there for this bevel end. So this is this types of, you can see this one is this types of configurations or fabrications there. Technical specifications: whenever we will design or we will make the technical data sheets in any projects, then we must follow these technical specifications. So we have to include these informations in our technical data sheets also, so that we can purchase a perfect Venturi meter as per our project requirement. So what are the information we must include in our technical data sheets? Fabrication codes and standards. Generally we follow different types of codes and standard, sometimes as per client requirement, but some international standards are there to follow. For Venturi meter we can follow ISO 5167-4, which is used for orifice and TP type instruments. So dash 4 is for Venturi meter. So fabrication codes and standards. Next is body material. So basically body is, except the flange, everything is body, but this body again distributed in two parts. One is conical or cylindrical part, second one is throat part. So this area is called throat part, straight area is called throat part, rest area is called conical sections or cylindrical sections. So sometimes throat can be of different material, but in most of the cases the throat material and other part of this body will be same material. That's why we have included the body material and throat material, otherwise rest material can be same. We have a particular experience in a project where we are taking the different material for this throat and different material for this other part of this body. The reason is body we can take the as per the PMS or pipe material, but this throat material will be minimum stainless steel. Due to the restrictions, there can be erosion of liquid. So to prevent the erosion of this throat, we have to take the minimum stainless steel material, because stainless steel material are more smoother than carbon steel material. If pipe is already the 316, then there is no any particular requirement for this. Otherwise, if we are considering the carbon steel or low temperature carbon steel, then we have to consider this throat material which is different material. Then flange type, size, and rating. So type and size will be as per the PMS only. Like normally we consider the raised face flanged, and if piping using different types of like FF flange or RTJ flange, then we have to consider. Normally for a very high rating, we can consider the RTJ flange like 900 or 1500. So as per the PMS, we can consider the type of flange, and size will be as per the line size. So if line size is 10 inch, then the flange size is also will be 10 inch. Both the flange will be of the same size because pipe size for both end will be same. So 10 inch will be the size of pipe and flanges. Again, type we have discussed that we can take the RF, FF or RTJ as per requirement. Finish will be as per the project requirement. Normally we consider 125 to 225 mu AARH, and material will be same as PMS or piping. Then the wall thickness will be as per the vendor recommendations. Beta ratio, it is the same we discuss in orifice meter. So beta ratio is the ratio of downstream, or we can say the D2 upon D1. What is D2? D2 is the diameter of throat and D1 is the diameter of upstream body. And beta ratio ranges is same as orifice, like we can consider point from 0.25 to 0.75. Calculated pressure loss, it can be achieved from sizing calculations, so vendor can provide it. Throat diameter, which is also provided by vendor. Tap type, size, quantity and locations. So tap type means sometimes we consider the NPT thread and sometimes we consider the PSP. So here we will consider, normally we consider the NPT taps, and size will be minimum 3 by 4 inch, half inch, 3 by 8 inch. These types of sizes can be used. Quantity, for one transmitter at least one HP and one LP tapping is required. So if you want to take two transmitter signals, then we have to consider the two pair tapping. For one transmitter, one pair tapping is required, and for two transmitter, two pair tapping required. For three transmitter, three pair tapping required, because in some cases we can use number of multiple transmitters with same orifice or same Venturi meter. So at least one pair tapping is required for measurement. So all the other spare tapping can be used as a plugged. So we require the stainless steel plug also to close the spare tapping. Differential pressure at full scale. So in sizing calculation, differential pressure at full scale will be provided. That can be used for calibration also. Full scale flow is also available. Like generally we consider the 10% of maximum flow, that will be the full scale flow as per our requirement. The same will be considered by vendor also. Sometimes they can just little bit regulate, so it can be modified like upper limit or lower limit. Calibration range can be provided with the help of differential pressure at full scale flow. So from 0 to that differential pressure at full scale is the calibration range for the transmitters. Process connection type and size. Already we have discussed, it is the flanged connection. So process connection type is flanged. Size is at the line size. Straight length requirement, as per the ISO 5167, there is a straight length requirement that we will discuss in some slide. So this is the technical specification which is used to prepare the technical data sheets of Venturi meter. This is the straight length requirement of DP type flow elements. Already we have discussed in orifice. So these types of design is available, like single elbow, two elbow in same plane, and two elbow in same plane. So these types of different conditions are available. So this is our element. This is our element. So A is the upstream straight length and B is the downstream straight length. And this is the beta ratio. As particular beta ratio, we can find out the A value and the B value. Here we can find at the particular beta ratio. So this is the straight length requirement. This is our standard requirement, but sometimes vendor recommend the different straight length requirement. Ultimately that will be the final value. Technical data sheets of Venturi meter. Definitely in engineering design projects we need to prepare the technical data sheets of Venturi meter. So we need to find out the total number of Venturi meter in our PNID. Then we will prepare one by one technical data sheets for each, because based on this data sheet only we will get the inquiry from different supplier and we will review technically. Again we will select the particular supplier which is suitable for our project. So that supplier will be our uh, main vendor which is going to supply the instrument as per the technical discussions or clarifications and documentations. Before prepare the technical data sheets of Venturi meter, we must need to read the PNID, piping, material specifications. We need to get the process data sheets from process department and the client specifications also for flow meter, because there will be some particular requirement from client side. So we need to take care in this technical specifications. So as we have discussed in different flow meter, some general information, process data will be required to prepare the technical data sheets. The same things here also. We have the PDS from process department. So process data we have to fill here as per the process department document. General information also we can put from the piping and instrumentation diagram, which is called PNID also. So from PNID we can fill this information, from PDS we can fill this information, and this information we have to fill as per our technical knowledge or our experience or database. Everything we can fill, like the type and design standard, as we know that ISO 5167. Body material we have to follow the PMS. Then we can get the body material. Throat material also we can get. Throat diameter and length we will get from vendor documents, whenever vendor document and calculation will be received. So this data will be filled from that document. We know that this Venturi meter is flanged or welded, because in some applications we use welded design, but in most of the applications we use flange design. So if you are using the flange design, then we have to provide the data for flange also, like what is the size rating, what is the uh, facing, what is the finish. These types of data for flange we need to provide. Otherwise this data will be not applicable if we are using the welded design. So for where we use the welded design, like in some like cryogenic applications where leakage is not permitted, because if we talk about the leakage, then there could be more chances in leakage in flanged connection in place of in comparison of welded design. In welded design there is not any chances for leakage. So in that critical applications where leakage is not permitted, we use welded design. So in that case we not need to mention the data for flanged. Tap type and quantity already we have discussed, like in project there will be either NPT or BSP connection types. Quantity we must know that in PNID if we have only one transmitter, then at least one pair tapping is required, and spare tapping also can be there, but that is depend on vendor. But if there is three transmitters used in PNID for this Venturi meter, then definitely at least three pair tapping is required. So we have to ask for three tapping. Again, few information we have to provide, like cylinder entrance length, conical convert length, and conical diverge length and conical diverge angle. So this data is from, you can get it from this figure also. So this is straight length, this is the conical length, this is again straight length, this is again conical. So this conical length and angle, this information we have to provide. So this information we cannot provide because the sizing is from vendor side. So vendor will provide the this length and angle value. So we have to fill this from the vendor data. Beta ratio is also part of calculations. Calculated pressure loss is also part of calculations, and maximum differential at full scale is also part of calculation. So from calculation we can fill this data. Full scale flow, we can choose either, we can follow the sizing. Calibration range, yes, we have to put the calibration range based on the sizing. So from 0 to maximum differential at full scale flow will be the calibration range of the DP transmitters. Straight length requirement, we can fill minimum as per the ISO standard, and we can wait for the vendor information. Once vendor information will be received, then we can update the data sheets. And plug material, for spare tapping, wherever we will use the plug, so that should be for SS material. And some purchase data, this information we can fill like PO number, model number, manufacturer name, as per the available details we can fill this data. Vendor calculation review, this is the particular vendor's calculations for a Venturi meter. So normally whenever you will review the sizing calculation of Venturi meter, so what you need to do or what you need to check from the calculation. So first of all, you will check the pipe data, like whether vendor have considered the right data for pipe or not, like what is the pipe size, what is the pipe schedule, what is the pipe material, what is the pipe, if schedule is not available, then what is the pipe ID is there. So this data we need to check it from this calculation. Again, we need to check the process data, whether the correct process data has been considered or not. If not, then we can comment it and revert to the vendor. So vendor will submit resizing, so we can check it once more. If the pipe data and process data are perfect, then we need to check the beta ratio, bore diameter, maximum differential at full scale flow, calculated pressure loss, and calibration range. So this data we need to take and we need to consider in our technical data sheets. And also we need to compare the calculated pressure loss with our allowable pressure loss. Calculated pressure loss should not be more than allowable pressure loss. If it is more, then we need to discuss with process department sometimes. If process is agree for this increased value, then we can go ahead. Otherwise, we have to go for other meter. So normally these value we can check from the sizing whether this is given or not, and this can be used in our technical data sheets. Dimensional drawing review. Once the sizing calculation will be okay, approved by us, then vendor will submit dimensional drawings for our review. So we will check the particular tags with particular calculations and our data sheets also. So normally whenever we will review the drawing, then we need to check again PNID and PDS and our technical data sheets and vendor calculation, so that we can make every document aligned, because this is the stage where we are approving every documentation technically. After that, the instruments will be in manufacturing process, so that in that case if we make any changes, then welder will not permit it. So if we will fail to provide the any details at the particular moment or any comment, then we must have a loss, or we must provide the change order for uh, particular tags or some particular tags. So we need to check the drawings carefully, and we can check what types of data. First of all, we must check whether the tag number is correct or not, model number is correct or not, number of tapping is there or not. So these are the tapping. You can see these are the tapping. Basically, these 1, 5, 6, this every marked information are considered in bill of material with quantity. So item number 1 is inlet cylinder, and this is the material of this inlet cylinder, and the quantity is 1. Definitely 1 will be there. So this is the cylinder, and this 2 number is what conversion cone. So you can see this is the conversion cone is there. This 2 number is conversion cone. This is the cylinder types of design, and this is the conversion cone types of design. So 2 number. And what is the angle of this conversion cone? 21 degree. Again, this is the straight length. You can say this is the straight design. So this straight design is called throat. So this is the Venturi throat. Okay. So Venturi throat material is different for this particular Venturi meter. You can see this conical convergent, and this inlet cylinder is of carbon steel material. However, the throat is of stainless steel material. Again, the fourth number is divergent cone. This is the divergent cone, and the divergent angle is 15 degree. Again, the seven number is outlet cylinder. So this is the inlet cylinder, this is the outlet cylinder. If there will be flange, then here and here will be flange. Although this is the bevel design or welded design, so we cannot use the flange. So there is this types of design for welding basically. So this information we need to check. Again, 6 number is tapping. So tapping with plug, you can see there is a plug provided. So 6 number is plug of 3 by 4 inch, and the material is A350 GRLF2, which is loose supplied. And 8 number is tag plate. This is the tag plate 8 number. 9 number is adapter. So this is the adapter, where this adapter is used for tapping basically. So if we take it off plug, then we can make the tubing here in uh, tapping. So these all the things will be there. We need to check it so that any person or any engineer cannot be confused whether what is this and what is the use of this particular items. So this is tapping, which is plugged. We can take it off plug, and we can consider this tapping for our HP and LP tubing, which is used for DP type transmitters. And this L is the total length for end to end length, which is very important for piping basically. So these drawings we will review, and also we will share to the piping department, because for installations and for modeling purpose also, this L length is very much important. We can share this information to designer, so that they could not make a mistake to model it. And this tapping orientation is given look lights, where this tapping is 45 degree. Although the tapping location is different as per the requirement, we will discuss in next slides. So these types of details also we need to provide to the piping department or to the instrument department to make the process connections or tubing, so that they can prepare the hookup drawings. Some installation details are available as per the different types of process media. Like in last drawing is showing the tapping locations based on the fluid. Like this is the liquid fluid, this is the wet gas, this is the dry gas, this is the steam applications. So we can consider the tapping point based on the fluid. So this you can see, this is the 4 o'clock to 5 o'clock, like this tapping can be there, this tapping can be there, or this tapping can be there. So in other language, you can consider it is the horizontal or below horizontal line tapping. So this is the horizontal line and tapping is below horizontal line tapping. For wet gases, you can consider the above horizontal line, either on 45 degree this side or this side you can consider. This is for dry gases. So either you can consider the this side or this side. So this is the horizontal tapping. This is the horizontal tapping. For steam application, slightly lower than horizontal tapping. So for steam applications, always remember slightly lower than horizontal. For dry gases, we can take the horizontal tapping. For wet gas, we can consider the 45 degree above to the horizontal line. And for the liquid applications, we need to consider 45 degree to the bottom or horizontal line. So these are the different view of the tapping or transmitter or Venturi meter based on this tapping orientations. So here this is the side view, this is the horizontal installation of gases. So you can see that the upside tapping is considered for the transmitter. This blue color is the DP transmitter, and this is the three-way valve manifold. So basically this is the representation only, this is not the actual drawing, this is the representations. This is for horizontal line and this is for vertical installation of gases. This is the horizontal installations for the liquid and this is the vertical installation for the liquid. This is the horizontal installation for the steam applications. Again, this is the vertical installation for the steam application. So these types of installation can be there in the site. Some reputed suppliers are there in the market: Vika, Rosemount, Tectrol, General Instrument Consortium. So we can purchase from these reputed supplier. Some figures are given here for Venturi meter. Like you can see, this is the around 100-inch Venturi meter. So you can see how large can be Venturi meter. And this is also a Venturi meter from our supplier. So this is the Venturi meter. Thank you so much.